Okay, question 5 is reaction rates, which is normally quite a difficult stoichiometry question somewhere. Acids and bases, and this normally has quite a tricky stoichiometry. There's also a lot of words, so we need to take notes of some of the words, I think. So they say here excess dilute hydrochloric acid and sodium thiosulfate. So that one is obviously the hydrochloric acid. And so the other one would obviously be this thiosulfate thing. There we go. The concentration of HCl is 1 mole per decimeter cubed. The same volume of HCl is used in each run. The time taken for the cross on the paper under the flask to become invisible is measured. So that's basically the rate. How long it takes to happen is going to be the rate. And the smaller the time, the faster the rate. So 5.1, definition question. It's a change in concentration of products or reactants per unit time. So that's the definition of reaction rate for 2 marks, I would think. Then they want the independent variable for this investigation. So now you are measuring, see here, this is where it actually gives a nicer example. You are measuring the time. So the independent variable is not that one. You measure the dependent variable. So this one is dependent. What are you deciding? What are you choosing? What are we changing? We are changing the volumes of the Na2S2O3. We are changing the volumes of the sodium thiosulfate. So you've got options as to how you want to say that. So for 5.2, you see it's not really the volume, it's the concentration, because if you add more water, the more water you add, the less of this you add, the concentration changes. So they are asking you to work out what the independent variable is. So you are doing the volume of Na2S2O3, and then you're adding more water to it to decrease the concentration. Then for 5.3, they're asking you to calculate P, which I think some people are going to find quite difficult. However, the number of moles is what you need. The concentration of the 50 centimeters cubed, the 40 centimeters cubed, and the 30 centimeters cubed. The concentration of all three of these volumes is 0.13 moles per decimeter cubed. Because when I add no water, the concentration is 0.13, which means this one has a concentration of 0.13, this one has a concentration of 0.13, and this one has a concentration of 0.13. The difference is you're adding more and more water and less of this. So for example, and I'm making up numbers, if this volume has 8 moles in it, this volume will have 7 moles and this volume will have 6 moles. You're getting less moles. Same concentration, but less moles. The way I like to try and explain it is if you made up a big liter jug of Oros or Energade or Powerade, if you poured it out to a whole lot of little cups, all the Energade or Powerade or Oros or whatever it is in all the different cups would taste exactly the same. It would have exactly the same concentration. However, the smaller cups, if you drank the entire cup, you would have consumed less Oros than if you drank the full liter. But anyway, the concentration of that volume, that 30 centimeters cubed, is 0.13. You can see that's what they did here. And so what you do is you have a concentration and you have a volume, you work out number of moles. You do it because you can. Here is the concentration. It's the concentration when you added no water. The concentration of the 30 is this number as well, which means you have this many moles. However, you've added water to make a total volume of 50. So now you divide that number of moles into a volume of 50, and you get 0.078 moles per decimeter cubed for your value of P. Then for 5.4, they are saying when 0.21 grams of sulfur has formed. So they're talking about this one over now. So the sulfur that forms is the reason why you can't see the X anymore. They told you in the story that it's something about the time taken to not see the cross anymore. That's because you're making solid sulfur. So they want you to calculate the average reaction rate with respect to sodium thiosulfate in grams per second. So 0.21 grams of sulfur formed in run 1. It took 20.4 seconds to form 0.21 grams of sulfur. However, for 5 marks, they are asking you about this one. They're asking you about this one. So they are giving you information about sulfur, and they are asking you what happened with this thing. So you work out number of moles of sulfur, you have a mass, you have a molar mass, you work out number of moles of sulfur. Okay, let's see if we have it here. Oh man, those are all those ones. I don't want any of those. Okay, so you work out the number of moles of sulfur because you were given the mass of sulfur. Then you use the ratio to work out the number of moles of sodium thiosulfate, which is the one they asked you about. Then you work out the mass of sodium thiosulfate because they want it in grams per second. So they said grams per second, so that means you need to get a mass, and you basically just divide the mass that you calculated by the time that they gave you for run number 1. So you work out the number of moles of sulfur because you have the mass of sulfur. You have the mass of sulfur, so you can work out the number of moles of sulfur. And then once you have the number of moles of sulfur, you can work out the number of moles of sodium thiosulfate because the ratio is 1:1. And then once you have the number of moles of sodium thiosulfate, you can work out the mass of sodium thiosulfate. The reason why they're doing that is because this says grams per second. And then when you have that, you divide it by the time to get the rate, grams per second. So in order to get grams per second, you need to take mass in grams and divide it by time in seconds. Okay, so for 5.5, they wanted to draw Maxwell-Boltzmann distribution curves, which is very weird. But they wanted to draw one at 20 and one at 35. This is a weird graph because the lower graph is actually hotter. So you get a mark for labeling the axes. The y-axis is number of particles, and the x-axis, you need to say some sort of energy. So kinetic energy works. Average kinetic energy is essentially the temperature. But you need to say, I think you probably could have got the mark for just saying energy, but they're obviously giving you the best version for the memo. Then they both need to start at 0. You have no particles with no kinetic energy. The A1 is higher than the B1. The peak of B is lower than A, and the peak of B is more to the right than A. So that wasn't too bad for 4 marks, I don't think. Although, these are a bit weird only because the energy is over here and the number of particles is over there. But I don't think it's too complicated. They are very big fans of asking these questions for some other daft reason. Then they say you need to explain it in terms of collision theory. So at a higher temperature, you have more molecules have the sufficient kinetic energy for an effective collision. So I normally do this version with my classes. When you're talking about the temperature, the higher the temperature, the more molecules have an EK or kinetic energy greater than the activation energy. So the activation energy, for example, will be that red line. You can see that the A graph has a smaller area than the B graph on the right hand side, which means the B graph is hotter because more molecules have an energy greater. Bigger energy means more to the right. So if more molecules have a greater kinetic energy or energy greater than the activation energy, you'll have more effective collisions per unit time. Per unit time is a very important phrase. So your option 1 for 4 marks, you say, and then your option 2, you can argue it just by saying a lower temperature rather than a higher temperature.